Hi, welcome back, guys. So, after the great response at the previous videos, we come back with a different video. So, instead of now in the previous videos, what we were doing is we were designing the entire system in a one long video, so it might become boring for you guys to view the entire video. So, now we are going to change our approach. So, what we will do, instead of designing an entire system, we will try to break it down into simple small problems and do it in a multiple videos, right? So, so the bigger problem statement for ourselves is, let's say we are designing an Instagram now. So for this video we won't design the entire Instagram out there in the single video. We will try to break down some features and try to cover that only, and in the upcoming videos we can cover the other concepts, right? So, for this system, let's say Instagram, we know that Instagram is a huge platform and it has multiple features. So in this video, what we are majorly focusing on, one feature, that is creating post, create and update or delete post. In Instagram we can create a post, right? So our system must support normal text based post as well as media, like we can create a reel, that is a video form of content, and images as well, right? So it should support both the thing. And the one more thing is, while creating a post, one more thing we should cover in this is feed generation. What is feed? Whenever you are watching other people's videos, so you should be able to see the post created by the people who you are following, right? So that is called as feed generation. So only these two parts we will cover in this video, and rest of the things we will cover in the other videos, right? Yeah. So again, the functional requirement are as listed here. Now we will try to determine the scale of Instagram, and then based on that we will try to derive the non-functional requirement for our system. So coming on to the scale part of Instagram is a huge platform. So we can consider the similar scale as like WhatsApp. So let's say we have 100 million daily active user on Instagram, or even a 1 billion user we can consider. That's not a bad choice either. So there are 1 billion daily active user, and we can assume that out of this, each user posts once a day. There are few users who don't post even in years, but there are few people who post multiple posts, 10 5 10 posts in a single day, like creators, right? So this is a fair assumption we can go with. So number of posts per day comes out to be 1 billion users are there, each is posting one post. So there are 1 billion posts in a day. 1 billion is roughly 1 into 10 to the power 9 posts, right? Now coming on to the number of posts per second, that would be simply 10 to the power 9. And in the previous video we calculated that the number of seconds in a day is 86,400. We can roughly consider it to be 100k, 10 to the power 5, 10 to the power 5 seconds. So this comes out to be roughly 10k posts per second. Yeah, that's a huge scale. But coming on to this, is not considering the WhatsApp that we have 500k requests per second. This is not too high, because the read to write ratio in Instagram is super high. If we have assumed that one user is posting one video each day, but in terms of consuming a video, we all are consuming more than 100, or in some cases thousands posts per day, right? So we can fairly assume that we are consuming 100 posts per day per each user. Each user is consuming this much post, right? Each user consumes 100 posts, or I should write read 100 posts per se. So the point of this is simply our read to write ratio will be 100:1, right? So the number of reads are much higher than the number of writes in our case. Yeah. So one more thing is that, so the number of reads are super high. So so this is the scale we have assumed. Now we will try to take out some non-functional requirement out of this. Non-functional. uh, so yeah, first thing, our system should be highly scalable in order to support 1 billion users, right? 1 billion now. Second thing is, coming on to the cap theorem again. So if you need a video in order to understand what these concepts are, you can comment and I will bring up the videos for that. For coming on to the cap theorem, we want our system to be highly available, at least creating a post and reading a post, like feed generation part. Our system should be highly available. So availability, we are preferring availability here over consistency. Consistency we generally prefer for a system where we might have a issue of race conditions kind of thing, right? Or transactions are involved. Yeah, in that case. So, so our system would be 99.9% uptime should be there. Always try to quantify your non-functional requirement. That helps a lot, right? So this is there. Now the latency should be super low. Are we considering the search? Yeah. So we are considering the feed generation. So low latency should be there for feed, for like if I'm scrolling Instagram and out of sudden my feed is empty, I will feel like a broken experience, right? So there should be super low latency for feed generation. For feed generation, we might have seen that on Instagram it immediately refreshes our feeds. So yeah, these are the basic non-functional requirement for our system. So now we will quickly go into the system design for this high level design. Basically we will follow the same procedure that we are doing. I am not considering the entities and APIs. They are pretty much simple. Here we can verbally discuss about the entities. Will be simply a post, a user will be there, and a feeds will be there, right? So these are the entities, and APIs will be pretty much for creating a post or CRUD operation over post. And for feed generation, we will simply call a API to refresh our feed. So this will be the two APIs that we will have. All will be simply a HTTP call. So we are coming on to the high level design. That is the most interesting part actually. So yeah, so we will be again going with the same architecture. There we will be having a users will be there who will be calling to our API gateway. The purpose of the API gateway is authentication, authorization, and routing us request to the correct server. Since we will be going to use since we will be going to use that a microservice architecture. API GAT. So this will be our API gateway. Now the number of the services that I can think of right now is one for creating a post. Let's say post service, we can call it post service, and the other thing will be the feed service, right? Okay, so this will be the feed service. Feed service is here, so we'll be having a feed service. Now let's see how the entire flow will be. Yeah, so I can get some more space for database and all. So user will make an HTTP request in order to create a post. The API request will pass through a API gateway. It will go to redirected to our post service for creating a post, create post, right? For creating a post, it will go to our post service, and once it is created, it will be stored into our post DB. Let's say post database, we can call it. Yeah, post DB. We will discuss about what type of database this post DB will be and all the things once we satisfy our functional requirement first. So coming on to the part of feed generation. So what, how will be generating the feeds? The one approach is whenever a user will ask me to get me the feed, we will simply call it to our feed service. Now feed service will simply, the user who is demanding, who is requesting the feed basically, is get feed for this user. So what we'll do, we'll be having the user id into the headers for security reason. So whenever a user will ask for the feed, what we will do, we will simply check is all of the followings, whoever users, the whoever people this user is following, we will go into their the following list and try to fetch their latest post and try to show it to the user, right? So we'll simply call our a use post service. For first call will be simply to get all the followings, and then the next call will be to our database in order to fetch all the posts that are done by the followers, right? So this way we can generate our feed for the user. This is the basic high level design that suffice our both function and non-function requirement. Coming on to this creating a post part for media and text, what we will do, first let's discuss that, because that's the easy part that we have discussed multiple time by now. So how the post will be created, again we'll go with the blob storage, because we don't want to bombard, we don't want to utilize, since if we are trying to create a post with a media via our server, so it will take too much computation power, because the video might be of 20 MB or might be higher than that. So our service will be highly, it will consume high, too much computation power of our server. So we will try, what we will do, we will go via pre-signed URL path. So what we'll do, whenever user will ask for uploading a media, what we will do, we will simply send him the pre-signed URLs, to which you, instead of going via server, it can directly go talk to our S3 like a blob storage in order to upload the video out there. So yeah, with the help of pre-signed URLs are basically the URLs with through which we give access to our storage to the client directly for certain amount of time. After some time, this pre-signed URL will automatically expire. So pre-signed URLs. This is how other platform like YouTube and all upload the video quickly without wasting the server's computation power. So this will be done once the, then at the, after uploading a video to a certain URL, while creating a post, we will send the media URLs into our post request while creating a post inside a post metadata, right? So this will be how the flow will be. Yeah. Now once the post is created, the post database we will store into our post DB, and then it can be read by feed service in order to do that. Yeah. Now let's go into our non-functional requirement, right? First is high scalability in order to support 1 million daily active user. Yeah, we can always scale our server horizontally in order to suffice the high scalability, but our system should be highly available. Yes, it will be. Now coming on to the low latency part for the feed generation, what will happen now, we are good, our solution is pretty much good for the post generation and uploading the media part, so that is perfect. But now coming on to the feeds service part, so how feeds is generated. Now if we go with the current approach, what we are doing, we're trying to fetch all the following and try to get their post from the database. That is too slow, right? It will be having the high latency for our users, it will be like the broken experience for them. So instead of generating feed while reading, when it is requested, when we are trying to read it, what we will do, we will try to generate the feed at the time of creating a post. So whenever the user is creating a post, we will try to generate the feed for all the users who are following him, right? So what I'm trying to say is, oh sorry, so yeah, just making it a bit lower so that we can have space there. So yeah, what I'm trying to say is, whenever a user is creating a post, instead of directly storing into our post DB, what we will do is, we will put all the posts into the queue. Give me some more space so that we can create a queue there. Yeah, and why I'm just trying to decouple our service so that we don't need to do things synchronously. It will help us to do this stuff asynchronously. So what we will do, we will create a Kafka queue in between. So all the posts which are created by the users will go into the Kafka. Now from here, what we can do is we can write a consumer here which will read the posts from this queue. This consumer will read the posts from this consumer from this Kafka, and what it will do, it will try to update the feed for all the followers of this particular user who created the post, right? Inside the Kafka we will have the event of the post, and there will be the user ID of the post whom the user have created. Now you can simply query our user DB or followers DB, and we can came to know who all follower or following of this user, follower list and following list of this particular user. Now where will be stored these feeds that we are generating at the time of write? So what we will do instead, if we are reading something from database, it will be slow, so we will try to do something a quick access kind of thing. So Redis comes to our rescue, right? So we will create a Redis here, Redis cache. So here, while our Kafka consumer will write the feed for each user here. How the Redis is basically a key value store, so how the things will be stored here, let's discuss this now. Again need some more space. So yeah, Redis is basically a key value pair. So what we will do, for each user we will be storing the feed inside our cache. So against the user ID we will store all the post IDs. This is basically how the feed is, right? Feed is basically what, a collection or a list of post IDs. So for each user the feed will be generated individually and stored here. So for each user we will be storing a list of post ID. So now let's go through the flow again. Whenever I am creating a post, I have created a post, the post event will go into my Kafka stream. Now from here my consumer will read, and it will try to get all the users, all of my followers, and try to put this particular post that are created into my friend's feed. The user ID is my friend's user ID, and post ID is the current post that I have created. So this will be how the entire flow will be. Now instead of reading the feed from our database, now what our feed service will simply do is read it from here, right? So this is how we can achieve it. But one problem with the approach is this will look perfectly fine for the users like you and me, but this won't scale. So basically the process that we are doing, we call it fan out on write. What? Fan out on write. Let me write it here itself. We are fanning out, like we are fanning out our request at the time of creating to all our users. Fan out on write. But let's assume Virat Kohli posted something. Virat Kohli has roughly 300 million followers, right? So now Virat Kohli has posted a post. Now what our consumer will do, it will try to write to all the users. So there will be 300 million writes, right? That will be too bad and might crash our Redis cluster, or that's a completely bad idea to go with. So for the celebrities, what we do is we will again what the feed service will do is, for celebrities we will define our functions and consumers such that for the users having too much followers or a celebrity type of follower peoples, we won't do fan out on write, we will do it fan out on read. So whenever a user is requesting a feed, at that time we will try to read the post DB and try to accumulate the feed for them. So this is called as fan out on read. How it works is basically, how this will work is, now let's go through the flow. User is trying to get his feed. Now for all the normal users, for his normal followers, we will try to read the feed from this our Redis cache, and for celebrities we will try to get it from the post DB and try to merge the entire feed and serve it to the user, right? So this will handle the case of celebrities as well. So yeah, this will be how our high level design will look like for the system, right? This is too bad here. High level design. Yeah, this will be how our entire high level design will look like for this system, like creating and updating post and feed generation. The important thing here is like this one, for the celebrities, how the feed is calculated. Now we should talk about our post database, how it will look. as we discussed earlier, there will be 10k posts per second, right? And on certain like high peak, we can consider it to be a 10x of this, so it will be somewhere around 100k posts per second. So that is still not too high, but still high enough to not to be handled by Postgres database, right? You might have got that by now. So what we will do, since our post doesn't have a fixed schema kind of thing, so we should not go with a SQL database here or any RDMS for that purpose. We should go with non-SQL database. Might be we can go with Cassandra or DynamoDB. So let's say we are going with Cassandra DB here. Our post DB will be the Cassandra one, and what all things will be storing here. Let's say we are having a post table out here. If you want a detailed video about how Cassandra DB internally functions, you can